Hello guys, welcome back. This is the sim. I wanted to run a couple of frames so I can create a moving geometry to collide with this. And what I'm going to do is I'm going to create a box. I'm going to view this and let's take a look at the box. Let's move it. I'm going to use a simple geometry first, and then I will show you how I use the robot, the Gundam robot as a collision geometry. Let's add a transform. I want to make this box fall. This is good. Yeah. Let's move the pivot. Here, and let's say it's up high. So set it here, and then frame 30 we want it to go down. Okay, cool. Let's add some curvature to this. Sorry, I meant the ease in time. Okay, let's see what we get. Yep, and I'm going to add a trail node to compute the velocity. It's very important to have the velocity and then we have velocity. Cool. So the normal way, the classic way, is to use a static object and then provide a VDB for that object and then use a deforming geometry. Now this method is really slow, especially with complex geometry, and I'm going to show you a method using VDB that doesn't add a lot of overhead. So I'm going to add a VDB from Polygon, and I'm going to compute the an SDF, which is the surface. One second. Yeah, so I'm going to create an SDF, which is the surface. I'm going to fill interior. And this is going to be computed every frame. Okay, I'm going to lower the resolution so it's faster to work with. Yeah, this is good. And the next thing, we need to create a velocity vector. So I'm going to click the plus sign here and type in vel. And then we want to sample the point.v for the velocity. Okay, we need two things for this to work. We need a surface field, which is an SDF, and we need a velocity vector. I'm going to call this out collision SDF, and then here I'm going to go under the let's turn this off. I don't want the wind at all. So I'm going to create a source volume, and I'm going to change it to collision. Okay, now with an SDF, the settings are not correct yet. We need to change a few things. We need to change this to -1, and then under the SOP to DOP, the surface field is called surface by default, and so I'm changing that to map correctly. And then the velocity is not called collision val, it's called val. These are my values from SOPs, and then everything else is the same. And let's point to that out SDF, collision SDF. It's not going to be visible in the viewport, but it's gonna work. So let's hit play. The geometry is not going to be visible in here because there is no geometry. And the main advantage of this method is it's going to inject velocity properly into the sim. So if you have, for example, a building falling and you want a lot of dust to be kicked off as it hits, you can get that super easily with this method, and it's independent from the complexity of the mesh. You can have 50 million polygons moving, and once you convert that to a volume, you're not going to have any issues working with that. So by now, I think this frame, the smoke should, the object should start falling. See, I don't remember where we did the timing, to be honest, so I'm gonna pause quickly and then we'll continue once it reaches frame 25. Hey guys, so this is the result. I simmed up to frame 32 and this is the collision with the box. Now you can see that the box is moving through the volume rather quickly, but it's not, there is no there's nothing inside the volume. Everything is removed properly, and we're also getting all kinds of interesting forces passed from the volume into the sim, and this is very important because it's gonna make the integration a lot better between the two subjects. Now we have something in our sim that is very unique. And let me, maybe I can find the render version. 1 second. So we have something very unique in our sim, which is when we have that loop, that fast moving object is going to be used for temperature, and then and anything that is fast moving is also going to be used as temperature. So there is a loop basically. If we take the smoke and just move it using another object, that velocity information, it's going to be copied to the temperature. And look at this, because of that feature, look at the feet of the robot. It's not dragging the temperature only, it's not just dragging the hot stuff here with it, it's making anything that basically all the static smoke is now fast moving, and it automatically gets copied to the temperature. And with this, see the hand, for example, yes, it has some stuff, it's dragging some stuff from the top, but it's not, it's actually making the smoke becomes hotter, and it's getting copied to the temperature. Look at all these interesting effects. Those are not just from within the sim, that's from that's not just from the collision by itself, that's from our solver that's happening, and with this as well. Now the velocity of the robot, of the animation, is being passed into the sim, and that's what's making also all these interesting shapes. There's the two things, the temperature being copied and the velocity is transferred as well. So and you can see now with a fast moving object here, there's no interpenetration between the box and the sim, which is very, very crucial to get some high-res collision. And you can see it, you can see all the details here. Let's take a look at the temperature. Very cool. Let's take a look at the temperature and see how it's changing. I want to turn off all the lights. Actually, yeah, that's fine. We'll leave the lights on. It's hard to see. Let's take a look at this side, and let me preview it. So the next thing is creating these SDFs can be rather challenging with production meshes, and unfortunately I don't have a magic trick for dealing with that. Most of the time I end up using a for each loop and generating a tetrahedralized mesh like we did in week 1 with a tank, but I do that every frame when I have a fast moving object, and I transfer the velocity if it's not copied correctly, and you will have an okay mesh. Depends on how complex the geometry that you have. Depends on the model. For example, sometimes you have to fracture it into a lot of Voronoi pieces and then generate Voronoi tetrahedralized mesh for each of those Voronois and then transfer the velocity. I'll explain that in the next video, but I want to show you guys the result here. And you can see there is some velocity, there is some fire being created, but we have a lot of interesting visual there in the intersection between the box and the sim, and a lot of shapes as well. And remember, we have to increase the resolution to get all the interesting details. We can also increase the velocity in the object. We can also increase it in the sim here. So I can set this to 2. And then let's go to the solver. I'm going to increase a few settings. I want to run a high-res sim using a mid-res sim using settings of 3. And I also want to increase the noise from the gradient. So I'm going to set this to 60, actually 50. I'm going to set this to 6. And I'm going to let it run, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.